talk today is about AI limitations, and it's important to know what is AI. When we're talking about AI, what does that mean? And AI became popular for most of the public and a lot of people around 2023. This is when OpenAI's ChatGPT really took off. But actually, AI has been around for quite a few years, even before this. And we saw that in 2012, 2014, we're seeing really fantastic models for AI that were coming on the scene. And so this is not something that started in 2023. And in fact, it's not even something that started in 2012. All the way back in the 1950s, we were having these conversations around what AI is. So this is the origins of AI. And since that time, we've actually had a couple of summers and winters, and there's been this progression, regression of what we're doing. And all of that has led us to where we are today. But actually, the big boom in artificial intelligence came not really from fundamental new architectures or anything really fancy. A lot of it came from the gaming industry and the fact that GPUs became wildly popular and accessible, and there was a lot of push on GPUs. So before this time, I've drawn a little line down the center here of this chart. Before this time, a lot of our AI was driven by a CPU. A CPU is something in your computer, good at doing lots of different tasks, but it's not very good at machine learning. And if you tried to do some of the types of machine learning that you see today on your CPU, like on my personal computer, you'd find that it's just not really practical. So a lot of the improvements that we're seeing came from the proliferation of GPUs. The thing to note is that all of these advancements relate to something called machine learning. AI is a fairly broad term that relates to a lot of different things, but machine learning is what really people are talking about when they're talking about AI today. And so for the rest of this talk, I'm not going to say, here's this great AI thing. I'm going to be talking about machine learning because that's really where the advancements are coming from. And you can take a course in machine learning and you can, code up these a lot yourself. But at the end of the day, what machine learning does, what machine learning is it's trying to fit a function to data. So it's part machine and it's part learning. And what that's doing is fitting a function to data. So what do I mean? Okay, well, let's just say we have a problem that we're trying to solve. Machine learning tries to solve a problem. In this problem, we're going to have a series of input and a series of output. The input is going to be something like a coordinate, so 0, 0, and the output's going to be 0. If you are, steeped in the literature in this, you'd identify this as an AND gate. It's a logical AND gate, pretty basic. It serves a very useful purpose, though, for teaching. So one of the ways that you could solve this problem is you could just load this idea into a dictionary. And if you want to follow along, you can follow that QR code. It links to a Google Colab notebook, and you can run some of these scripts yourself if you'd like. So the simple way to solve this problem of the logical AND gate is to load it up into a dictionary and then just find the answer. Like if you didn't know, if I asked you to define the word aardvark and you didn't know what that was, you'd probably just look it up in a dictionary and then you'd know what it was. The same thing could happen here. We could just code all of this in a dictionary and figure out what it is. The problem, of course, is that this doesn't scale very well, and it also requires a lot of knowledge. So for scale, we have to hold all of the contents of this world somewhere in some kind of storage bank, and that can be difficult to carry around. And knowledge-wise, we have to know everything about this world to have correct answers. So we have to know the problem really well. A second solution is to capture all of this information in a neural network. This is a single layer neural network. And that is just a function that we can run our input through to get a correct answer. So this little neural network here does work if we're trying to find the answers to that AND gate I showed you before. We have this bias term. We're going to add to that this input X and our weight. And then we're going to add another input Y and our weight. And then we're going to check, this is the activation function. We're going to check if the answer is more than or equal to 0 or less than 0. And that'll give us the answer. So if we run this through this mathematical representation of the problem, we actually will every single time have the correct answer that comes out. Of course, the problem again is that we have solved this scale issue because all we need to do is carry around this mathematical formula, but we haven't solved the knowledge issue. We still need to know exactly what these weights are in order to run the input through the function to receive the correct answer. So this is the problem. We don't know the weights. And this is the solution of machine learning. The value of machine learning is that it allows us to learn what these weights are, and we don't have to know them beforehand. So we don't have to be experts in this domain. we can just have a computer work on this problem. And it's what the computer is going to do is it's going to run this loop over and over and over again. That would be called an epoch in machine learning. And eventually it will learn what the bias term should be, what the weight should be, and it'll solve the problem for us. So this is a simple, I'm actually not going to run this today. If you go to that collab, you'll find it. This is coding up that neural network in a sequential model. And then, we can run it through the input and receive the answer. So this has solved our scale problem because we can now just run these inputs through functions. And it's also solved our knowledge problem because we don't have to know what the weights are a priori. We can just ask the machine to figure out what they are. So the reason I'm bringing all this up is because it really sets the stage for what machine learning is. Machine learning is all about adding a function to data. And this neural network that I showed you here looked very basic and, it was very basic. It's just a logical AND gate. But what's important to know about all of machine learning is that at the end of the day, these things are just doing that at a very large scale. So this is an MNIST digit recognizer. This is a very popular training problem in machine learning where you give the computer an input of handwritten digit and it should be able to tell you what that is. And if the network in the middle here looks a little familiar, it's because it is the same type of network that we saw before. It's just there are lots of different networks together, so there's many different layers, and those mean that there's lots of different weights. But it's the same type of idea where we're running an input through a function and we're receiving an answer in the end. Let's get to this panel, some brief introductions. So Eric and Matthew, if you want to unmute yourselves and introduce yourselves right now, let's with Eric, because you're the most left on my screen.
Yeah, sure. Sounds great. So my name is Eric. I'm a grad student at MIT in cognitive science. And before that, I was a law student at Harvard. And I research how humans and machines understand and interpret the law, as well as the implications of those findings for broader questions of law and policy. And very happy to be speaking to you guys today.
Hi, everyone. My name's Matt. Great to be here. Thanks for inviting me. I'm a JD PhD student at Yale. My PhD is in political science, and happy to be here talking about some work I did at Stanford last summer.
Yeah, so one question I have for both of you, you have these really, pretty technical papers that you wrote, but you also have a very legal background. And so I'm wondering, how did you get involved in this field? How did you come to write these papers? If you want to talk about that.
Yeah, sure. So like I said, I do political science. And so I've been interested for a while in sort of text as data or traditional forms of natural language processing. Political scientists have been studying the judiciary for decades now, trying to understand judicial behavior, judicial decision making, how law gets made, does law matter? Is it just policy preferences? These sorts of questions. And this literature has almost exclusively focused on these sort of easily identifiable markers of outcomes, i.e. just judicial votes. So does the judge vote to affirm or vote to reverse? These are easy to code and people draw inferences about this, about judicial behavior. Obviously, as lawyers, we understand the limitations of that approach because it's actually judicial opinions, not judicial votes, that are the law in our common law system. And so I've been interested in this problem for a while and using these new tools that have come out, as you surveyed in your opening slides, over the last 10 years of word embeddings and that sort of thing to understand judicial behavior. And then when ChatGPT came out, I saw, like many of us, I was quite surprised by how capable it was. And I was like, wow, this is like a really important research frontier. So I wanted to get involved and start learning more about large language models and using this more in my research.
Cool. Yeah, great.
Yeah, that's I guess in my case, I kind of got into this field sort of serendipitously. So when I was in law school, it just turned out that I was interested in legal doctrine as I was in how legal doctrine was drafted and interpreted. And so to get a better sense of clarity on those issues, I thought it would be helpful to learn more about the empirical side of how language is created and interpreted. And so in law school, I took a few classes at MIT in the department where I currently am. And while I was there, I met my current advisor, and the two of us kind of hit it off, and I started working on projects related to law and cognitive science. And I was kind of in the I was kind of following large language models for quite a while, and including GPT-2 and GPT-3. And so then when ChatGPT came out, I was kind of somewhat familiar with the earlier versions, and was, I guess, kind of like Matthew, was kind of thinking it was kind of the new frontier, and that kind of led me to work on, I guess, this paper and a few other papers that are kind of in that same direction.
Yeah, and I think another question I have is, so like, if you're just a law student and maybe you don't have a technical background, like, how do you get involved in these projects? Like, do you just read up on it? Do you try and find collaborators, or do you have any advice for somebody who's like really amazed by ChatGPT and wants to like research it but doesn't quite know where to start?
Are we gonna go in reverse order now again?
Sure, yeah.
Sure. So yeah, I guess I guess I would kind of give two pieces of advice. The first one is kind of just mindset. So, I would say to be patient and determined and not be daunted. I mean, I would hear people say it's hard to learn technical skills after undergrad, and I think to some extent that's true. But especially things like programming, I think are especially learnable, and even though they might be a bit hard, the payoff is very worthwhile. And then the second thing I would say is kind of strategy oriented, and in that regard, I kind of encourage people to not learn technical skills in a vacuum. I instead try to figure out what sorts of questions you're really interested in, and then try to build up your skill set to try to answer those questions, and simply try to learn skills that you might think are later useful without having a concrete goal in mind. And I think that's especially true if you're a law student, because at this point you're already spending a lot of time with your legal studies and already have that expertise, and so it's both kind of not necessary and also not efficient to just try to learn a bunch of technical skills without any sort of, I guess, goal in mind. And then, aside from that, technical skills are easier and more fun to learn when you're applying them to something that you're passionate about. So that's, I guess, what I would say.
Yeah.
That's great. Yeah, I would add, because this research frontier is moving so fast, there's a lot of space to make a contribution. This isn't physics. This isn't, econometrics. The amount of work you need to put in to make a advance in like one of those fields that people have been doing for hundreds of years is a lot. This, nobody knows what's going on. I mean, people do, but the pace of innovation is happening so quickly that it's both easy to sort of get up to speed on what the cutting edge is, and to yourself add a contribution, just because it's so vast and uncharted terrain. And I'd also add that you don't need to be like a technical wizard necessarily to make a contribution, right? The next, no one outside of industry has the compute to train the next generation of these models. So as academics, our value add has to be somewhere else. We can't compete with what OpenAI is doing in their labs, right? What we can do as lawyers is bring our substantive and specialized knowledge to the application of these tools, and I think there's a lot of value add we can have.
Yeah, that's great. And I think follow up, we're going to kind of dig into these papers that you guys both wrote. So I'm wondering, Matthew, if you could just give us a brief overview of hallucinations and the work you did looking into when ChatGPT hallucinates.
Yeah, sure. So I'm sure most people here are familiar with this, anecdotal reports about hallucinations. You probably saw there was that Manhattan lawyer last spring who got in trouble for filing a case with fake citations. SCOTUS blog had a piece early on about Ruth Bader Ginsburg, ChatGPT saying that Ruth Bader Ginsburg had dissented in Obergefell, the landmark gay rights case. Obviously, she didn't. So these sorts of things are what we call hallucinations, when the model is making things up and doesn't seem to know the difference between fact and reality. And so we saw this. We saw these anecdotal reporting in the media about this, but we realized there wasn't any systematic empirical data actually about the extent of these hallucinations, the provenance of the hallucinations, the correlates of hallucinations, and so we wanted to just study that more systematically to give some concrete numbers on that. And so what we did is we crafted essentially a set of queries about American case law, exploiting the fact that in the US, because of our common law system, the law is fractured across time, across jurisdictions, across courts, and using that to gain purchase on understanding where and when these models tend to do worse on knowledge information. So we put together a set of queries ranging from simple ones like what's the citation of the case, who wrote the case, what was the disposition of the case. Those are easy to verify. To more complex queries that are usually the backbone of legal research. What's the factual background of the case? What's the holding of the case? What's the subsequent appellate history of the case? The things that normally, as attorneys, you'd have to go and do research on. Do these two cases stand in tension with each other? Does one overrule another case? And so we asked a set of these queries systematically across a sample of all federal case law to profile and understand the correlates and the frequency of hallucination. And the main takeaway, I won't get too much into it, we can talk more about it maybe, is just hallucinations happen a lot, so watch out.
Yeah, no, that's really great. That's a fantastic overview. And Eric, you looked into something similar, a limitation of ChatGPT in terms of the bar performance. Could you tell us a little bit about that?
Yeah, definitely. So when GPT-4 came out last year, if people remember, probably the most widely touted of its capabilities was its bar performance. So basically, anywhere you would look, it would claim that GPT-4 got 90th percentile in the bar exam. And I remember being a bit skeptical about this from the outset, given that, at first the leap in performance on the bar from GPT 3.5 to 4 was larger than that for any other exam. Also, half the bar exam is essays, and GPT-4 performed pretty poorly on other essay exams, both overall and relative to GPT 3.5. And then third, the bar exam doesn't release percentiles. And so I remember thinking, it's kind of strange how they were able to get that. And so from there, I guess one last thing is just, working with these models, it didn't seem like it was getting, 90 percentile work out of them. And so I first just looked on OpenAI's website and technical report to see where they got the percentile estimate and couldn't find anything. And then looked at the paper GPT-4 passes the bar exam, which is a paper written by external folks who administer the bar exam for OpenAI. And in that paper, they don't focus on percentiles, except for one footnote where they mentioned that according to a publicly available chart, GPT-4 would score 90th percentile on the bar exam. But turns out, there's some unofficial charts from Illinois, and if you look at the most recent one from July, it gets 68th percentile and 48th percentile in essays. And so this is a bit confusing until I remember recalling that there's two bar exam dates, one in July, one in February. July is when most people take it, and most people who take it in February failed in July. And turns out that if you fail it once, you're likely to score low again. And sure enough, if you look at the most recent February table, GPT-4 gets 80th percentile among February Illinois test takers. And so then I thought, okay, so July is obviously better than February, but even July has people who take the exam the third time. And so if you really want to get a good measure, you should just look at first timers, or better yet, if you want to know how well it does against lawyers, then you should be comparing it to only, actual lawyers who passed the exam. And so if you do those estimates, you get something much lower, like 48th percentile overall compared to lawyers. And especially on the essays, it's getting 15th percentile in essays compared to lawyers. And so those are the main results. Also went and replicated the multiple choice score using the OpenAI API, and then looked at different hyperparameter adjustments. And then on the essay side, I also pointed out some kind of serious issues with the essay grading, which call into question the reliability of those scores. But yeah, happy to dig into the details more.
Yeah, no, that was a fantastic overview of both of those papers. And I think one question that I've had as I've been reading these papers is that each of them talk about this idea of a trust gap in between what the model is outputting and how much we should trust that. And it's really hard to tell how much we trust these outputs. And so I'm wondering if you guys could talk a little bit about that trust aspect, what are some ways that we can know, hey, this is like a warning sign, this isn't right, versus how can we increase trust in these models? What are some things we can do? And I guess you can answer either of those questions or both of them if you like. And maybe we'll just start with Matthew and work back.
Yeah, sure. Yeah, I think one way to address the trust problem is to ensure that these models are properly calibrated. By which I mean that if a model is 100% sure about something, or says it's 100% sure about something, it had better be 100%. It had better be right 100% of the time. And so we see I think a lot of trust issues arise when there's miscalibration of these models, that it's hallucinating something, for example, very confidently, at the same confidence when it's not hallucinating. And so there are ways to sort of fine tune these models or adjust them post hoc after their initial training iterations to make them more calibrated, which I think would ease user trust by simply exposing that like uncertainty information to the user, right? So like I think maybe hallucinations would be okay if the model told the user, hey, I'm only 50% sure about this answer, and that was actually true. Like the 50% was right. So the user could say, okay, in expectation, I'm just rolling the dice here, and it's on me now to like I can take this for what it's worth. The user can update on that information. And just maybe maybe a caveat of this though is that there's some interesting like impossibility results by like John Kleinberg and others, if people are interested more in this, about fairness in algorithms and models. And one of the problems of calibration is that it comes at the cost of certain metrics of fairness that people are interested in. So we often talk about wanting these models to be fair, right? We don't want bias. People sort of use that word a lot, maybe imprecisely. But sometimes there are trade-offs between different kinds of bias and the things we want to optimize for. So we want, say we want to increase user trust. That's great. That may come at the cost of other things. And there's some evidence this is a technical limitation. It's not like we can't have our cake and eat it too. So if that's the case, then there's really a normative trade-off to be had here, which is where lawyers can come in and make a normative contribution about what are the things we value here, and what are the things we want to optimize on. That was a bit long-winded, but hopefully that's useful.
Yeah, no, I think that's great. And it's absolutely a trade-off. Like you saw in some of the models that I was, the toy models I was building early on, one of the parameters was, here's what I'd like the model to do. And I'd like to check this on accuracy. I just care about accuracy. But in other problems, there's a lot of other choices and a lot of other ways to split the cake. And so it's important to think about all of those. That's fantastic. Eric, do you have anything to add to that, or maybe other opinions?
I think that was a great overview. I mean, maybe just one small thing is, I guess one thing to keep in mind is not to have AI check its own work. So it seems like, especially on the hallucination side, some of the stuff that's gotten lawyers in trouble is the AI will hallucinate, and then instead of just checking the citation, the lawyer will be like, "Oh, are you sure this is a good citation?" And then they'll say yes, and then that's kind of leads the lawyer to trust the AI on faith, and then get in trouble. So yeah, I guess one of the good things about a lot of this stuff is you can verify it online. So even if it might be a hard search problem initially of getting the citation, once GPT-4 or whatever generates a citation, you can then check if that's like a real citation. And so I feel like some of this stuff is not as fatal as some of the other issues, but that's, I guess, just one thing I would have.
Yeah. Well, and having that ground truth, and that came up in Matthew's study, right, where you guys were seeing the outputs that ChatGPT gave, but you needed some way to assess how correct that was, to look at like hallucinate, like what is a hallucination, right? And same with checking bar pass rate, which can be easy when you have a multiple choice question, but harder when it's an essay. And so, yeah, I appreciate the limitations there. So, thinking along the lines of this normative aspect of these models and the output of these models, and I did see some hands raised, and I would say if you want to keep them up, that's fine. If there are a ton of questions, I can end a little bit early. So if you have questions, put your hand up, maybe give me a signal there. But otherwise, I was thinking about going until about 12:40 or so. So, I'm wondering, what are some guardrails that we might think about when we're trying to make AI, machine learning outputs safer, or what can we think of that might be good directions, to go to like reduce the trust? Like, is it good enough if we just have a little disclaimer like OpenAI has now on ChatGPT? Like, hey, I think the disclaimer says something like, don't fully trust this, like look into your own work. Is that enough? Do we need more? Do we need regulatory solutions? Do you guys have any opinions on those? And maybe we'll start with Eric and then go to Matthew to reverse it.
Sure. Yeah, I mean, I agree with what Matthew said at the end of the last question, which is this is a ripe area for lawyers to step in and kind of show off their expertise and figure out, what are the things we want to be optimizing for and how do we concretely implement that with a legal solution. I think it's a very complex topic. I mean, one fear I have is that there might be some sort of an action versus omission bias. So, there's not very much legal regulation currently in this area. I think we definitely do need some. So the short answer is no, I don't think it's enough to just have ChatGPT have a disclaimer. But I also think we should be careful to not, we should be just as concerned about avoiding implementing bad regulations as actually just implementing regulations. And so that's, again, one thing I would say. But I guess in general, I would say this is a very complex topic that I think we need very smart people in law thinking about these issues. And yeah, in that regard, I would just kind of, encourage folks to work on this topic.
Cool.
Yeah, I agree. It's complex, and I'm not a huge policy guy myself. I feel like I usually don't have much to add to these policy discussions just because I don't have a lot of expertise in evaluating these things. I guess, I mean, one thing I'm generally in favor of, I think, is disclosure requirements and transparency requirements, both on the developer end. OpenAI is purportedly open, though no longer, as this is one of the reasons that Musk is suing OpenAI right now, is because they gone back on their founding promise. I don't know if he has standing to bring that lawsuit, but that's another issue. But the broader issue is that we no longer know what exactly the data are that are going into these models, how much compute is being used to train these models, and this is problematic for various reasons, depending on for various reasons, but for short-term reasons, long-term reasons, and I think disclosure and transparency is usually sort of a light touch regulation. It might, tends to appeal to libertarians who just, believe as long as everyone has perfect information, the market will solve things. So I don't know, that might be a good place to press on. Of course, you could come up with more, harder sticks as well, but I don't want to speculate about that.
Yeah. Well, I mean, people are speculating. Now's the time. If people are writing about this area, it's really active. So I guess, and one of the follow-ups I've had about thinking about these limitations, and like we were talking about how GPT, it did okay on the bar, right? Like, not great, and then it's been better and better and better. And so, do you guys see a point in time in the future where, like, us worrying about these limitations, like, is ChatGPT good at the bar? Like, of course it's good at the bar. Does it hallucinate? No, it never hallucinates. Like, do you see that as being a place that we're headed in, or is there always going to be problems? Like, are we always going to have issues? And so we need some additional help, like, to get us there. Like, we shouldn't wait on technology to just solve all these problems for us. Do you have any opinions on that? And either one, anybody who's prefer to jump in first, I guess.
Yeah, sure, I'll go. On the hallucination side, I don't see this being a solved problem anytime soon. This is contra many of the representations that are being made by companies, commercial companies like Lexis, Westlaw, Casetext, that are claiming to have solved the hallucination problem. I don't believe them, and I don't think that'll happen anytime soon. In our paper, we cite some sort of formal mathematical results that suggest that, at least at the token level, language models must hallucinate to some extent. So then now you can try to suppress hallucinations post hoc. Then you solve the problem detecting hallucinations. And then particularly in the legal context, like the law, I think is such a hard problem for these models. It's a really hard test for them because the law is so contested. Like case law, or like in our common law system, is built up by judges writing opinions over time. It's like in what sense are those opinions fact, right? You know, like the law is contestable in a deep sense, and so I think there are sort of ontological questions about what is true facticity that that the hallucinations in some sense I think will always be a problem.
Yeah. Great. Eric, if you have anything to add?
Well, yeah, since that was addressing the hallucination side, I can just, I guess, address the, I guess the bar exam or capability side. I think, yeah, AI will, I think AI will ace the bar exam at some point, perhaps as soon as the next model or the one after that, especially the multiple choice section, if depending on what you count as acing. Whether it will be able to do all of the things that a lawyer needs to do on a daily basis, I'm not so sure, but it will definitely improve. It will be an indispensable tool at some point for sure. I do agree with the law being a tough task. I mean, I'm kind of competing mindsets because I agree with what Matthew said. On the other hand, law is in some sense a paradigmatic use case of large language models because language is central to how the law is drafted and interpreted, and there's a lot of training data for law. I mean, but it's also it's very plausible that we're just running out of training data with law, and we've kind of hit a ceiling effect relative to other capabilities, and that in other domains there's much more training data being naturally created on a daily basis. And so I'm of competing mindsets, but I guess I do think the specific issue of the bar exam will be solved. I think that's an interesting take. I mean, the essay portion I think is a bit tricky, definitely for the multi-choice, and it's the same thing though. We thought about, like, you look at AlphaGo before that, and the Kasparov with chess. Like, if a problem becomes small enough for a computer to just figure everything out on, then it of course answers the problem, right? And so it's an interesting point. Okay, so probably just in the interest of time and giving people enough time to chat, I'm going to end the recording here. I have some more questions that we'll get to if there aren't audience questions, but I want to give everyone enough chance to talk. So let me end the recording now.